Hello and welcome to another complete Cambridge IGCSE PE lesson, the second topic in Chapter 5, Applications of Force. As always, you'll learn exactly the information you need to sit your final exam, and today you need to be able to explain the forces exerted by gravity, air resistance and muscular force, to define ground reaction force and explain its importance to sprinters, and to draw and interpret force diagrams for performers and objects in sport. In our last lesson, we explored the relationship between force and movement by referring to Newton's 3 laws of motion. In order to better understand movement patterns in sport, however, we need to identify the different forces acting on a body or object and explain how each force influences performance. So let's have a look at those forces now. The first is gravity, which can be defined as the force that attracts an object towards the centre of the Earth. Gravity affects all objects equally and causes them to accelerate down at a rate of just under 10 meters per second squared. The second is muscular force, which is a push or pull applied to an object provided by muscular contraction. This is the force that we produce, and it's behind almost all movements observed in sport. Next we have air resistance. It can be defined as the frictional force that air applies against a moving object, and the faster we move, the greater its effects become. Our final force is ground reaction force, or the reaction to the force that the body exerts on the ground. Whenever we apply a force against the ground, for example during a vertical jump, a force of equal magnitude will be applied back against us by the ground, propelling us into the air. So now that you know a little bit more about the forces at play, our next step is to apply them to a sporting context, and there are 3 scenarios from sport that you need to be able to interpret. We'll start by examining the forces acting on a moving performer, and we'll use a cyclist as an example. The cyclist applies a muscular force to the pedals, causing the bike to move, and because the pace is slow at this point, air resistance only has a very small influence. As you can see by the size of the arrows, the forces are imbalanced, and as muscular force exceeds air resistance, the cyclist will speed up or accelerate. The force of gravity also acts upon the cyclist here, but it's balanced by an equal and opposite ground reaction force. As the cyclist continues to accelerate, air resistance increases until the forces are balanced. If neither opposing force exceeds the other, a constant speed will be maintained. Some cyclists have discovered innovative ways of minimizing air resistance so that they can achieve greater speeds without needing to apply more force to the pedals. Finally, muscular force lessens over time as the cyclist begins to fatigue. The force of air resistance now exceeds muscular force, causing them to decelerate or slow down. Our second scenario is for a sprinter in the starting blocks. As the gun sounds, the sprinter applies a muscular force to the angled blocks, and the equal and opposite ground reaction drives them forwards and upwards. Gravity pulls the sprinter downwards towards the track, so muscular force and the resulting ground reaction force must be large enough to overcome its effects. As the sprinter leaves the blocks, air resistance is low as they're still moving relatively slowly. As they continue to accelerate, however, air resistance increases until the forces are balanced and a constant pace is achieved. Finally, we'll examine the effects of force on an object in flight, otherwise known as a projectile. When we take a free kick in football, gravity will pull the ball downwards towards the pitch. The free kick taker therefore needs to judge the correct height and pace so that the ball clears the wall and drops in time to hit the target. The shape and surface area of a projectile will influence the amount of air resistance it encounters. Because of this, the air resistance acting on a football is greater than that acting on a golf ball, and has a significant impact on the distance and accuracy that can be achieved from a goal kick. The force applied as an object is released is determined by muscular force and will affect the distance of a lofted pass. Too little force and the pass will be intercepted, while too much force could cause the ball to overrun. Now it's your chance to put what you've learned to the test. Pause the video now to draw 2 stick figures and add arrows to illustrate the forces acting while accelerating and moving at a constant pace. Make sure you include force arrows for all 4 forces. The vertical arrows should be the same size and in opposite directions, as gravity is balanced by an equal and opposite ground reaction force. Muscular force is greater than air resistance here, causing the runner to accelerate. In this example, the horizontal arrows should be the same size, as muscular force and air resistance must be balanced if a constant pace is to be maintained. Well done, you've just covered everything you need to know on topic 5.2. Make sure you're comfortable with everything included in the knowledge checklist, and come back next time for the final topic in chapter 5, levers. As always, I hope you found this lesson useful, and I'll see you in the next one.